So these are just some pictures of sound being made, and so let's see if we can find or think of them in terms of basically the air having little disturbances made. So here we have a tuning fork, and this is a classic. Actually, we whack this one, and if we have the sound hole pointed to the sound hole of this one, it actually can begin this one buzzing. I think that is so cool. Of course, here we have vibrating strings. Here we have that little annoying ball thing in the whistle creating a disturbance. Here we have, depending upon whether you like the sound of the trumpet disturbing the air there, actually, and being measured here. And I believe one of the videos that you're watching recently talked about how you can, this is so cool, you know how you can take a glass and kind of take your finger over it and it makes a tone. Well, if you match that pitch with, let's just say, you know, grab your trumpet and match that pitch and up the amplitude, you can make your glass break. So we talked a little bit about metric prefixes, and one metric prefix we talked about was kilo, and hopefully we're all on the same page. Kilo means 1,000 times the base unit. So 1 kilohertz is equal to 1,000 hertz. Kilohertz. So I mentioned that because I mentioned that. So over here is a figure from your textbook, and it has, in terms of kilohertz, that's probably why I mentioned it, it has in terms of kilohertz what's going on with regard to us being able to hear that disturbance in the air. Well, if it's between 20 hertz, it's kind of nice and neat, and 20 kilohertz, in general, people can hear that. Now, our hearing does change as we age. I'm just warning you. So, now if it is a lower frequency, less cycles per second, we call that infrasonic. And if it is a higher frequency than 20 kilohertz, we call that ultrasonic. And you've probably heard of maybe ultrasonic cleaners before. So I just mentioned that because, and isn't this adorable, we have these dogs over here, and if you've ever heard of a dog, the technique of a dog whistle, that is actually in the ultrasonic region of sounds that we can't hear but they can. I think that is so cool. So just to kind of remind you that the frequency is related to velocity and wavelength, like we talked about before. And then one last slide, just kind of a random slide. These are actually, I believe, in hertz. And yes, they are in hertz. And these would be, for you musicians, the, how do I say this? The letters of the different notes. Okay, so here's C's and the various octaves, what frequency those would be. So I think that is so cool. And I brought in, this is a similar slide, but I thought it was cool because they have the instruments here, kind of how they line up with regard to overall frequency.